Okay, I figured before we moved on to looking at Newton's laws of motion, I thought it'd be good to show that how we can use Mathematica as a fairly powerful tool to handle some of the more tedious calculations that we have to do. So Mathematica you can think of as a super glorified calculator. So for instance, if I want to calculate 2 plus 3, I just type in 2 plus 3 and then you hit Shift Return and it tells you that the answer is 5. Okay, that's cool. And by default, everything works in radians. So if you want to know the sine of pi, it'll let you know that that's 0 and that the cosine of pi is -1, for instance. Okay, Mathematica is also very proficient with lists and matrices. If you've had a chance to play with it, you know that it represents a matrix as a list of lists. And so thinking about the example that we were doing, we can take a look at our vector A and we can say that it is 3, 4, 5. Again, Shift Return to evaluate that. And now you'll notice that the letter A changed from blue to black. That now means it's a defined symbol. So we can go ahead and look at our rotation matrices that we had come up with. So the first rotation matrix that we would come up with, R1. So to do a matrix, that's a list of lists. So that's why I have 2 curly braces. We said it was going to be the cosine of phi. Oops. And then the next element was sine of phi. And then the next element was 0. Okay. Now to do the next row, and Mathematica is kind of nice about letting you try to pretty print it at least a little bit. That was minus the sine of phi, cosine phi, and 0 for the next row. And then finally, we had 0, 0, 1. Now, Mathematica puts it out in this line form like this, which isn't necessarily the most readable thing. Now you'll notice the way you usually invoke a function is you write the name of the function and then you put the argument in square brackets. But there's more than one way to do that in Mathematica. So just as an aside, let's say that I wanted to calculate the sine of pi. This may seem like kind of a silly way to do it, but it'll get the point across. I go ahead and this slash slash means take whatever was in front of it and stick it in as the argument of the thing after it. So, and you can string these along, taking the output of one thing and sticking it into the input of the next. Where this kind of format is sort of handy is if we're wanting to view R1 as a matrix, it's usually easier to type slash slash matrix form, like so. And then you can see it puts it into something that you and I can actually read. Okay, by the same token, our R2 matrix was found to be cosine of theta 0 minus sine theta. Okay, and then the next row was 0, 1, 0. And then finally, the last row was sine of theta 0 cosine theta. And again, that doesn't look the most pretty, but we can take this last result, that's what the percent sign means, is just whatever the last result was, and we can pipe that through our matrix form just to see that we typed it correctly, and yeah, it looks good. So if we want, we can go ahead and multiply the two matrices. And the way Mathematica thinks of it is as a dot product. This comes from playing with tensors. So we can get our general rotation matrix by saying R2 dotted with R1. And then we'll go ahead and put the results straight into matrix form just so we can read it. And sure enough, that's what we found before. So similarly, if I wanted to operate those rotations onto my vector A, R2.R1.A, and again we can put that out into matrix form. And there's your answer there. Now that's all well and good, but what if we had specific values that we wanted to look at? That's not a problem either. Mathematica has a super powerful thing called rules. And if I type /dot, that means what's coming next is a set of rules, and wherever you see a particular symbol, replace it with the thing I tell you to. So for instance, we can let phi be 60 degrees. Now, since we work in radians by default, we have to tell Mathematica that it's degrees. And we can tell it also that wherever it sees a theta up in this previous stuff, to replace it instead with 30 degrees. Okay, and we'd probably still like to see it in matrix form at the end. Okay, and you'll notice that Mathematica gives it to you nice exact answers, but if you want to double check your work against what you did with your calculator, Mathematica has a function called n, so we can take our last result and stick it through n, which just says, can you make it numeric for me, please? And there is our vector A in our rotated coordinate frame. Okay, so that should be just a good start to help you learn to start playing with Mathematica. I think you can see that it's a lot easier letting Mathematica multiply matrices for you than you having to do it yourself.